Hi guys, so today we're going to go further into the sum of geometric sequence and series formula. So for the sum of a finite geometric sequence, you're going to be dealing with geometric sequences and you'll be finding the sum up to a certain term. So the formula for that is here. Now, sometimes notice that the upper limit is going to be up to infinity. So you will have another formula to apply. So depending on where they're asking you to stop in terms of the terms is which formula you would apply. So in the first case, we are only asking for the sum up to the 13th term. So we're going to apply the first formula. So S sub n equals a sub 1 times 1 minus r to the n power over 1 minus r. Now, I already know what n is because they're asking for the sum of the 13 terms in this sequence. So I'm going to replace all the r's with 13 just to start off with. And the only thing I'm missing from this formula now, the only thing I'm missing from this formula now is the ratio because I already have the first term. So to find the ratio, remember, you are just going to, let me just finish color coordinating here. You are just going to take each term and divide each term by its previous term, and it should give you a common ratio. For instance, 8 divided by 4 is 2, 16 divided by 8 is also 2. So since we have a common ratio of 2, we know that r equals to 2. And we have our first term already, which is 4. So I'm going to replace a sub 1 with 4, and I have everything I need to start solving. Now keep in mind that you want to solve for your parentheses first, and since you're dealing with fractions, make sure that you solve the numerator, press equals before you divide it by, in this case, -1. So just moving up here, I have 4 times 1 minus 2 to the 13th power would give me negative 8,191. And I would divide that by 1 minus 2, which is -1. So I know that two negatives will give me a positive. 8191 divided by 1 is still 8191. And bring down that 4. When I multiply these two, 4 times 8191, I'll get a total of 32,764. So that is the sum of the values of the first 13 terms. So what happens if they ask for an infinite? Well, we have that here. So I just want to go back so that you can see the formula before we get started. And since we're finding the sum of this sequence infinite to an infinite value, I'm just going to show you how it works, the proof itself, as well as the formula. So we'll start with the formula. A sub 1 over 1 minus r. Now, this looks a little simpler than the other formula in all honesty. So the first term is 3 over. We have 1 minus r. So again, you divide each term by the previous term because r equals to the second term divided by the first term, which should be the same thing as the third term divided by the second term. So dividing each term by its previous term, that would give you a common ratio of 0.1. 0.3 divided by 3 and 0.03 divided by 0.3. So that would be 0.1. So remember 3, and then make sure if you're putting this in the calculator and you just want to type this whole thing into the calculator, put the denominator in its own parentheses. Otherwise, it'll just divide by 1 and then subtract that answer to 0.1. What you should get after calculating is 3.33. Okay, so how does this actually work? Well, let me just put that first as well. I'm going to just note that mind you, you can round it. You don't have to put that there. So 3, 0.3. 0.03. Notice that each place there is a 3. There's a 3 in the ones place, then there's a 3 in the tenths place, then there's a 3 in the hundreds place, and then there will be a 3 in the thousands place, so on and so forth. So you can kind of see from the pattern here as well, if you were to add it, what the sum would be. All right, guys, I hope this helps.